The studies class, we were discussing about the importance of septic tank and how the function is, how it is going to function um, in the treating the wastewater which is going to generate, especially in the rural areas. Maybe we have left the studies class the explaining about how the scum layer is going to generate at the top and how the sludge is going to generate at the bottom. If you see the layer, how it is going to um, generate scum at the top, normally it looks like this color, and at the sediments you can see at the bottom even it is looking at that color only. At the hatch it is used for the removal of this whatever the accumulated scum after 15 or 20 years. Scum, it will be there, it will accumulate at the top and sludge is going to, and inlet, you can see the inlet is there, the wastewater it will enter. After some time, after 2 or 3 days, this scum is going to generate and it will float on the surface, means the density is very less, and a destabilized sludge, whatever it is there, it is going to settle at the bottom, and the remaining things, if it is not digested 3 to 4 days, after 4 days it is it will enter into the second compartment. There it is going to stabilize, or it is going to digest. So then, normally, which are the design details of this septic tank? Normally, detention period is very important component when we are designing the septic tanks, because for digestion process we have to give sufficient time for the wastewater to contact with the bacteria, because bacteria will not eat suddenly. If you keep for longer time, or it has some specified time is there, then only it is going to eat, because it is a biological process. Always the biological process is um, slow process rather than any of the chemical process. Chemical process are very fast compared to your biological process. So detention period, normally it is in between 12 to 36 hours. Normally it is 24 hours. One day they will use it. Means I already said that 2 compartments it will be there. In the first compartment it will be there for 6 hours, and the second compartment normally it will be depends on how we are going to design it. It will ranges from 6 to 12 hours. Then second compartment it will ranges from 6 to 24 hours. Means 0 to 6 for the first one. The second one it will be from 6 to 24 hours. Assuming the rate of sewage flow is 90 to 150 LPCD, and knowing the population to be served, total discharge is determined by V is equal to Q into T, where Q is the discharge, that is in either it is a meter cube per second or meter cube per minute or liter per D or liter per second, and all those things. And the volume of the tank, here we are going to design the total volume of the tank, that is given by the Q into T. T is the detention time. So means T, either it is in minute and all those things. Normally you will get the total volume of the tank. Once you got the total volume of the tank, assume the depth of around 1 to 2 meters. Then you take the length is equal to 2 times the B, means whatever the L it will be there, normally it will be 2 times the B. Then find out the whatever the area. Once you assumed the depth, then area can be calculated volume divided by depth. So once you made it volume divided by depth, so then you'll get the area. Then area is equal to L into B, and assume L is equal to 2 times the B. Once you apply that, you will get it, the L as well as the B. Then you have already assumed that that is the depth. So then you are going to design the dimensions of the septic tank. Some of the that is a simple method what we are going to design. Some of the rational method is there to design the septic tank. So normally the settling zone what we are talking about at the bottom portion of the tank, normally that we can call it as settling zone, where the sludge is going to accumulate. That is normally you assume it as 30 centimeter depth. Then digestion zone, that is the digestion zone, it is near to the scum zone. Then near to the scum zone, what I have highlighted previously, it will be provided as 0.032 meter cube per capita. Means that much space should be provided per person. It depends on the per person. This is a rapid or the rational designing process of the septic tank. Even this is also accurate than what we are doing it earlier by considering the volume or designing the volume. This is also a rough idea, and most of the time it is going to be correct. So sludge storage zone of 7.30 meter cube per 100 persons. Here it is. They will take the sludge storage zone, that is equal to 7.3 meter cube per 100 persons. For cleaning interval of 1 year is provided, and cleaning interval of 1 year, that has to be mentioned whenever you are designing the sludge storage capacity. This is for 1 year. For 1 year again you have to clean it, then you have to reuse it. Then surface area normally of 0.92 meter square per 10 liter per minute of flow is, means LPM, 10 liter per minute of flow is provided. Normally give the surface area of 0.92 meter square per 10 liter per minute of the flow should be provided. Then freeboard of 0.3 meter is provided, that is 1 to 2 meter, or that is freeboard of 0.3 meter, where the depth of 1.2 meter and length inch to breadth is 2:4 ratio. Of course, this is one more typical type of rational method of considering the design details of the septic tank. Then which are the different elements of the septic tank? This is how normally it looks like. Even if you see from the top, the normal inlet pipe, it will be there. There is an access port, scum layer. Then this is baffles. Baffles is one wall, baffle wall, which is made up of the masonry, which is going to separate the channels of the wastewater, which is coming from the left to right side. I already said it is a two compartments. Two compartments is divided with the help of the baffle walls. That baffle walls is made up of, I already said, the masonry structures. So in other point you have access port will be there. So means if you want to remove any of the sludge or wastewater from the any of the two tanks, then it can be removed with the access point only, or sometimes these access points can be used for the inspection purpose. Sometimes most of the time if the septic tank is not working, then it is better to inspect using the access point. Means even if you see whether the bacteria are there or not, or if the bacteria are not working properly, your digestion system will not work properly. It is just like our stomach. In our stomach also bacteria are there, but these are aerobic bacteria. It requires the oxygen. With the help of the oxygen, whatever we will eat, it is going to digest, and then once it is digested, um, the whatever you are going to release the energy is the same thing. The same process is going to happen inside your septic tank also. But the septic tank, of course, it is made up of the anaerobic process, but ours is aerobic process. Then, if the septic tank is not working properly, then using the access point, you can see what is happening inside. Even you can collect the sample, even see that, even you can test the samples for further improvements of the septic tank. Then they have mentioned two zones there, the clarified zone and the sludge layer. How exactly it will be there? How exactly the clarified zone it will be there below the the scum layer what we are speaking about. These are some of the treatment efficiencies of in this septic tanks. Normally, all this whatever the wastewater is treated, that we are measuring in terms of whatever the pollution load in the treatment plant, we are measuring in terms of BOD, the total suspended solids, grease. As these are three main things we are going to measure in the septic tanks. So of course, BOD, if you are talking about the average raw sewage, if you are talking BOD, normally it will be 308. So septic tank, if you see it, it will be 122 percentage. So normally up to 50 to 60% we are going to get. Then total suspended solids, it will be 316 at the initial raw sewage. Then average septic tank effluent, if you see it, after that it will 72 percentage removal. It will be roughly, it will be 77 percentage. Grease, if you see it, it will be 102 milligram per liter. If you see the raw sewage, if you test it, you will get you that much. Then if you take the sample from the septic tank, that is the end of the septic tank, whatever we are discussing, the average septic tank effluent, it is the end of the septic tank. Means after treating all the things, then whatever, if you are disposing that effluent to the soak pit, there we are testing it. Once it is tested, we'll come to know that it will be around 21 percentage removal. Normally it will be high only, that is 79 percentage. Means highest removal of this um, um, septic tank. In the septic tank, it is going to happen BOD, TSS, grease removal. So when you are using the details of this design of septic tank, normally the peak flow we have to design it, because we don't know. Once I already said that once you design the septic tanks, normally it has to come for um, uh, 30 to 40 years. Then we have to design it for 30 to 40 years only. Then we have to design it for peak flow. If number of users are there hundreds, then you have to use the peak discharge of 240 liter per minute. If you are there 150, then you have to use 360 liter per minute. If 200 people are there, then you have to use 440 liter per minute. If it is 300, you have to use 720 liter per minute. These are the standard design details um, for the peak discharge. Then what are the advantages of this septic tank? So it is very easy in construction. If you see the construction details, maximum stone masonry or rubble masonry is required. Then at the bottom portion and the top portion, then only you require RCC, and it is mostly of a square in shape, and when it is square in shape, the construction will be very easy. No maintenance problems except the periodical cleaning process. Of course, no maintenance is required except during some cleaning process. Of course, cleaning process it will be like 15-20 years. If it is there, if it is working fine, only when the problem is going to happen means when your bacteria will not work, that time, um, 2 to 3 years definitely you have to clean it. Then the construction is very less, because there will not be any special type of treatment is required. Only you have to construct it, then go on. So once you construct it newly, then you have to fill the water completely, so that whatever the water is there, it has to be first um, whatever the water is there, it has to be kept for 3 to 4 days. Then whatever the 3 to 4 days, it has to be stagnated. The stagnant water should be there. Then the stagnant water, it consists of many bacteria. Once it receives the human feces, automatically the digestion process it will start. Suddenly if you dispose it without filling the water, the digestion process will not be um, proper. Once the digestion process will not be proper, then it is highly difficult for the um, treatment. Then it will transfer the load on the other compartment. Once it is going to transfer the load on the other compartment, then the soak pit load is going to increase. Once the soak pit is going load is going to increase, then automatically the water will not be, the wastewater or this human feces will not be treated. The same pollution load is going to transfer to the groundwater as well as surface water. Ultimately we have to reduce the load on the surface water as the ground water. Effluent can be discharged without any trouble, because most of it is 100% it will be purified. It is suitable for the isolated community. Very little attention and skill attendance is needed. So that much skilled things is not required in this case. So the remaining things we will cover it in the next class. Mostly in the next class we'll start with the estimation part of the water tank, the soak pit septic tank, followed by the manholes. Thank you.